Okay, so this is actually for the next quiz. I believe it was quiz 7. This is using drop factors. I think this one is actually, the drop factor is the easiest out of most of the calculations, at least for me they are. So I want you to attempt the quiz. So I'm not going to show the quiz except for the last question. But first let's try to do, figure out the drop factors here. Let me just get my screen working so I can write on it. All right. Okay. Got to make it pretty color. All right, so right here's your formula, and if you need some help, you can go to this website here, thedosagehelp.com. There's a lot of different calculations that will help you. I feel like if you guys work through this and try to input different numbers to try to play around with it so you can practice, then you guys will understand it and be able to connect with it. So we have a volume over time times your drop factor equals your flow rate. So let's use this example. So there's an IV flow rate for 1,200 milliliters of normal saline to be infused in 6 hours. The infusion set is calibrated for a drop factor of 15 drops per ml. So you're always going to have a drop factor when it's asking for your flow rate. You need to know that. So the drop factor is 15 drops per ml. So let's try to, I think that's the easiest one to do first, is that actually the time to me is the easiest. So you have your drop factor, so that's going to be inputted later, but we have 6 hours. So we need to figure out how many minutes that is. So you always, when you see drop factors, you really want to find out, because you need to find out how many drops per minute. You have to convert your hours into minutes. So that would be right here, your 6 hours times 60, so that's 360 minutes. So when you see a different question, let's just say it says 12 hours, you're going to do 12 times 60, and that's your how many minutes. And now we're going to put our milliliters. So the order was for 1,200 mLs, so that will go here. And then you have to be infused over 6 hours, which is 360 minutes, and then times your drop factor per mLs. That equals 50 drops per minute. All right, I hope that makes sense. So now let's go to this one, which is calculate the IV flow rate for 200 mLs of 0.9 normal saline over 120 minutes, and your drop factor is at 20 drops per ml. So you're going to use the same drop factor formula up here. So your volume, so first you can get your 120, it's already actually set for you, 120 minutes, so you don't have to get your hours at this point. So you just put in your 120 minutes. So you put 200 mLs over 120 minutes times your drop factor, which is 20 drops per ml, and that equals 33 drops per minute. So let me go ahead and get to the other screen here. Let's see if it'll let me. Okay. So this one's a little bit different here. This is the one where the patient's prescribed, there's a 3-section, 3 answers that you have to get to. So patient's prescribed heparin sodium 18 units per kilograms per hour, and the weight is 123 pounds. You have 25,000 units available in 250 ml. So you're going to calculate the flow rate first, and then it looks like you have to rebolus. So you want to find out how many more units your patient received, and then what the new flow rate is. So how we're going to set up that formula is, I wrote it down here, I'm going to get my thing. Okay, so I hope you can see this, okay. First I want to go ahead and get my kilograms. So I'm going to get, let me make this different color so you can see it here, okay. So we have 123 pounds divided by 2.2. So hold on. 23 divided by 2.2. That's 55.9 kilograms per hour. So you have 55.9. So I'm going to just bring it up to 56 kilograms. All right, so we now have this one here, 56 kilograms in there. So now what you want to do is do 18 times 56, your 18 units times 56. And 18 times 56, it's going to give you 1,008. All right, so now we have 1,008 units per hour. So we have this so far. All right, so now what do we have available? We have available 25,000 units per 250 mLs. So let's do the second part of the equation. So this is what we have available here, 50 mLs. So I'm going to divide this divided by 250 mLs, and that gets me 100 mLs. All right, so that now brings me to 1,000 here divided by 100 mLs, because it's asking for the calculate the flow rate of mLs per hour. So we want mLs per hour. So these two are mLs, and the hour, which is just by 1, so it would be times 1. So all we have to do is divide 1,008. Oops, sorry, I'm calculating this. Divided by 100 times 1. That will equal your 10.08, which would round up to 10.1 mLs per hour. So that's your first one. It's 10.1 as it says below. Okay, so I hope you understand that. Now it says that the APTT is 40, so we really don't need to input this anywhere, so we're going to cross that out. And the protocol states to rebolus the patient. So rebolus means that I'm going to go ahead and give a bolus, a larger amount at one time. So either be IV push or fast through the IV, that's a bolus. Of 40 units per kilogram, and increase the infusion rate by 2 units. So I'm going to bolus them with 40 units per kilogram instead of 18 units up here. So all you have to do is change your formula, or you just change your numbers, 40 units per kilogram per hour. So you're going to do the same calculation. You already have the kilograms, which is 56. So you just do 40 times 56. That gives you 2,240. All right, so that's basically what you're going to bolus them in. I know it says this, but it's not. It's 2,240 units. Yeah, because if you take that, hold on, thinking out loud here, weight-based kilograms per hour, and you want to figure out how many units, divided by, and you divide it by 100. Yeah, this is the right answer. Units. Okay, so now you're going to increase the rate by 2 units per kilograms per hour. So that's going to be, so you already bolused them with this. Now you want to increase it. So the original order was 18, so you want to increase it to 20 units, 56 kilograms per hour. We still have the same what's on hand. We still have the 25,000 units over 250 mLs. It's the same. So that'll get you your 100. Okay, so let's do the 20 times 56. That equals 1,120. You divide it by your 100. You're going to get 11.2 mLs per hour. So that is this answer right here. So it's a 3-step question, but it's just, again, trying to figure out what you're looking for. So sometimes you just have to think a little bit before you even try to put a formula together. Okay, and that is it on that one. Sorry, it takes me a while to figure out how to turn this off here.